Today's learning target is I can use and construct scale drawings. A scale drawing or a scale model is used to represent an object that's either too large or too small to actually be drawn or built to its actual size. So you can see here we've got a scale model of the White House here, right? We can tell it's a scale because if not, these would be giants. But when you have a scale drawing or a scale model, the lengths and the widths and all the dimensions are proportional to the actual object. So it's the same proportions just on a smaller size or a larger scale. So when we have this sort of drawing or model, we have what's called a scale. And the scale tells us what the actual dimensions are based on the model or the drawing. So let's just take this one for example. It says 1 inch is equal to 3 feet. So if that were the scale for this White House, that means for every 1 inch on the model itself, it's actually 3 feet. So if this were actually 3 inches right here, this window, so that would actually mean the window itself is actually 9 feet up and down. And let's say it was 1 inch going across, well that means it would be 3 feet in reality. Let's take a look at this problem here. It says, suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? So I've underlined the information that I need, and I can see here that the model wing length is 4 centimeters. The actual wing length is 6 centimeters. So I'm going to jot that down here. So I've taken that information and I've created a ratio here. So 4 centimeters in the model in actuality is 6 centimeters. So 4 centimeters to 6 centimeters. Now remember, a scale tells me what 1 centimeter in a model would actually equal in reality. So I can create a proportion that helps me to find the scale. So in the model, I know it's 1 centimeter, and I want to find out the actual. So I'll put A for actual. And now I can use my cross products to create an equation that can help me solve this. So when I do that, I get 4 times A right there, and that's going to equal 6 times 1, or 6. And now I want to get A by itself, so I'm going to divide both sides by 4. Okay, and that cancels out, and now A is going to equal 6 divided by 4. And 6 divided by 4 equals 1.5. So my answer, my scale, is 1 centimeter. 1 centimeter in the model is equal to 1.5 centimeters in reality. So here's another example here. It says the blueprint of a skateboard ramp shows that its length is 11 4/10 inches. If the scale on the blueprint is 1 inch equals 6 feet, what is the length of the actual skateboard ramp? So here again I want to create a proportion. Okay, so I've written down the scale. I found the scale right here. It was also right here in the problem. Okay, so I have 1 inch is equal to 6 feet. Now I'm looking for the actual length of the ramp. So I can see in the model it is 11.4 inches. So I'm going to create a proportion. That's where the model is 11.4 inches, and I'm looking for the actual. So I'll put X in there for that. So now I can create an equation here, and I do that by doing my cross products. So I've shown the equation, X equals 11.4 times 6, and when I solve that, I get 68.4. So 68.4, and the label is going to be feet. And remember to show your work in today's assignment, right? So you start with your proportion, show me what equation you're solving, and your answer. If you come across a problem where your scale is in a fraction, so in this case, on a blueprint it says 1/4 of an inch equals 3 feet. If the length of the room on the blueprint is 4 inches, how long is the actual room? We're going to solve that similar to what we did with the other problems. So the first thing we'll do is we'll create a ratio. So we see that 1/4 of an inch is 3 feet. So I write that down as my ratio. Now, 1/4 of an inch, I'm going to change that to a decimal. So we're going to get 1/4 as a decimal is 0.25. And if you don't remember how to do that, make sure you check with me. And then I can help you with that. And then 3 feet is at the bottom. So it says the length of the room on the blueprint is 4 inches. So we're going to create that proportion where 4 inches is the top number, and I want to know how long the actual room is. So I'll put L for length for my variable. And so here again we'll use cross products. Okay, so I know that 3 times 4 is 12, and that is going to equal 25 hundredths times L. Okay, so 0.25 times L. And now I want to get L by itself, so I have to divide this side by 0.25, so 25 hundredths. And if I do it to one side to keep it equal, I have to do it to the other side. That cancels out. And when I solve 12 divided by 25 hundredths, I'm going to get 48. And I have to make sure I have my label. So it's 48 feet. So L equals 48 feet.